Hi, this is my submission for the challenge Customizable Apex Finance Calculator in Salesforce. For this challenge, uh, first I'm going to go through the demo and then going to explain you how I have built the calculator. This is a classic example of the service pattern or dependency injection. So if you are from the old school object-oriented programming, uh, you would know what a dependency injection is or a service pattern is. But I'm gonna go into the details after I show you the demo. So I'm on opportunity, and as requested, I've I have created a generate receivables button, and I have one opportunity school. So let me click on it. So let's click generate receivables. So you can see that these are all the receivables that are generated using the payers that are present on this opportunity school. When I say payers, so you can see that this is the opportunity school. So this is an school, and on the school we have school payers. This is a school payer, and that's the payer. And the payer has two receivable types, and he has calculations, and calculation has payout dates. One thing that I have noticed is, the complete data model is looks fine as it is. I've seen it and it is working good. One thing that I did was I made a small change to the payout dates. Payout dates is like a child object that is the last level or the bottom level. So every payer will have his own set of payout dates. Like I know that every pair will have his own set of calculations, and then every calculation will have its own set of payout dates. So what I did was to make it easier in the code to run the SQL queries. I added a formula field called payer, which will basically pull the payer ID from the top level, like the topmost level. That way it makes it a lot easier for me to basically query the payout dates using the payer ID. Anyways, I'll go into that. I'll show you the code where I have done that. But you can see that this is the screen. I haven't gone fancy with the screen because it was like just part of the requirement, and that was not a big requirement. But anyways, you can choose the receivables and you can save them, and they are saved successfully. You can see that they are saved successfully, and this is like the name, and you can click on them and you can go to the receivables, and this is all the receivables that are saved. If you see the calculations, they are exactly the same as mentioned in the example. So I'm gonna show you how the calculations are done as well. But coming to the main part of the demo of this challenge basically is how the calculations is done, and how are we preserving uh, the we are using how are we using the governor limits, like preserving them, like uh, doing a SQL queries or doing the DML statements. I don't know if I have a log, but let me see. Yeah. So this is the SQL, like the limits that I have been using to generate the receivables, and it doesn't matter how many opportunity schools that you use or how many payout dates or anything. It's gonna fall into the same number of limits because of the way I have built the code. The only way or only chance the limits might increase is depending on the complexity of your actual calculation class, and that too it I mean those limits are applied only once. So it's not like you have like your calculation class has like 10 SQL statements, and we have like 5 payout dates. So it's not going to be like 50 SQL queries, but it's going to be only 10 SQL queries or SQL statements. So it's done only once, and you can see that it's like fairly nothing. But let me come to the code. So what I have is a iReceivable interface, which is basically an interface in which I've created in Apex, and the only method that this interface is having is receivable amount. So any Apex class uh, that wants to do the calculation needs to implement this interface. So for example, from the challenge, we have two classes, calc CA in lieu and calc CA EPA. So what I'm doing is I'm implementing this iReceivable interface, and I'm returning the receivable amount. That's based on this simple calculation that use 4,000 into the attendance or like 1,000 into the attendance. It's a simple calculation or a basic example that they've given me, but that's what it is. So these are these two classes that are implementing this interface. So when I say service pattern, so what's the service class that is basically calling this interface? Doing it is the pricing engine. So the pricing engine is basically a service class here, and it does the dependency injection because the pricing engine will not know until the runtime which calculation it's gonna use. So during the runtime, it knows which calculation it uses, and then it creates the instance of that calculation dynamically and calls the receivable amount. So let's go and see what it does. So it basically generates receivables for the opportunity school. So you can send a list of opportunity schools. It identifies the payers from the opportunity schools, and then it builds the maps first, and then it iterates over the payout dates. So these are like the payout dates. So this is the only SQL query that I have used to get the payout dates for a payer. I do not wanted to like traverse through from the top branch to the bottom, like where I get the payer and then the calculations and then the payout dates, versus having just. So what I'm doing is I'm just using the payer. It's a new field that I have added. It's a formula field, and then this is part of requirement. The payer date must be equal to or greater than today. Anyways, and then uh, I'm building a map for every calculation as well. So once a calculation is done, I'm just storing it in the map so that it can be reused again, because a payout dates can be, I mean, for a calculation payout can there can be like more than one payout date. And this is uh, a statement that I'm talking about, classic dependency injection. So I'm creating a like instance of the interface iReceivable, and I'm like dynamically binding the class by using for name and new instance methods in Salesforce. Oh, and then I'm getting the receivable amount. That's after getting the receivable amount, it's pretty much easy. So on the payout rate, you have a percentage. You just multiply it by percentage, and you'll be getting the payout amount. And that's all. And for this thing, I'm also using an Apex class called payer wrapper, which wraps basically the payer with the payout dates. So also it's easy for me to do the calculation part. That's all. So if you look at the code, it's fairly simple. It's just one method and few interfaces, one interface and few classes. And for the generate receivables, it's a basic controller and a Visual Force page design. So all you do is like uh, use the controller to generate that page, and that's it. Uh, that's all about the challenge. And I don't know, I mean, but it's been like a long time since I've actually implemented a really good design pattern in Salesforce, and I'm glad that I'm able to do this with this challenge. I hope you like this. Thank you. Bye bye.